Potions class. Welcome to potions class, folks. Add a little bit of water to this flask. It's probably enough. Let's see. What am I going to add now? I'm going to add a little bit of phenolphthalein indicator. Just a bit. Let's add like 5 drops. No stir bar going. Now I'm going to add some phenolphthalein. How you doing there, Kion? Let's add some phenolphthalein, shall we? Excuse me, some, isn't that beautiful? That's sodium hydroxide, 20% I'm adding. Really pretty. Really nice. I'm just going to try to get this just a little bit. There we go. That's a little nicer. Little nicer angle. Turn this way. Just getting the lighting right. There we go, baby. That's what I'm talking about. Looks nice. A lot nicer. Add a little drop of sodium hydroxide here, and it goes. How you doing there, Caleb? And now what we're going to do is we're going to add a piece of dry ice, also known as solid carbon dioxide. Let's watch what happens. And it goes. Looks nice and spooky science, of course. Carbon dioxide is an acid, by the way, when it dissolves in water, and that's why you're seeing that color change. You see, phenolphthalein shows a variety of, not, I shouldn't say a variety, 2 colors. In acidic, it's colorless, and when it's basic, it's going to be pink. So I'm going to go ahead and add some base here to this. You can see that pink color grow in. And let's watch what happens as the carbon dioxide bubbles through. Dry ice is solid carbon dioxide. Pink color goes away. Yeah, let's add some more sodium hydroxide up here at the top. And that makes it go basic, but of course, as the sodium hydroxide bubbles through the solution, takes it back to colorless. So the carbon dioxide neutralizes the sodium hydroxide that I'm adding. Here, I'm going to just angle this just like this so you can see me adding up here at the top. It's up here. Way up here, I'm going to add drops of sodium hydroxide solution. And you can see when I add that, it's changing the color to pink. That's because phenolphthalein in a base is going to be pink. But of course, as the carbon dioxide bubbles through, changes it back to colorless. And again, that's because carbon dioxide is an acid when it dissolves into solution. Go ahead and do a... Oh, it won't explode, Modi. Hello there, Ro. It won't explode because it's not in a sealed container. Let's do some slightly different experiments over here in this container. This container over here is going to have universal indicator in it. I'm going to get this spinning. How does the carbon dioxide do this? So, Kion, it reacts with water. So what you get is CO2. What's up there, DJ? CO2 plus H2O makes H2CO3, which is carbonic acid. Yeah, let's check this out. Universal indicator over here on the right. I'm going to add a few drops of base. Boy, look at that gorgeous color change. Hydrogen monoxide. Help me out there, F117. I do not know what hydrogen monoxide is. Let's add a couple drops of acid over here on the right. Oh, yeah, we get a nice color change. Thank you there, Germany. Yes, I'm a teacher. What's in the left? In the left is some dry ice that's bubbling through water. I'm going to go ahead and, thank you there, player. I'm going to go ahead and add some, you can see it up here at the top. I'm going to add drops of sodium hydroxide to the water on the left. That's going to change it pink because the indicator in here is pink in a base, but then the pink color fades. That's hydrogen, dihydrogen monoxide there, Nighthawk. There you go, Neptune. Come on. Hey there, Michael. Let's add a little bit more base over here on the right. I added a big squirt over there, so it's changed to pink because phenolphthalein is pink in a base. But as the carbon dioxide bubbles through, carbon dioxide forms an acid, and that should neutralize. Thank you there, player. Thank you there, Zoe. It should neutralize the base that I added, changing it to colorless. AE21, we're making hydrochloric acid in our stomachs all the time, yeah? Absolutely. So that pink color, I can still see it. We just got a little bit to go, just a bit. Let's do it over here on this side. I'm going to add some hydrochloric acid over here on the right. Here we go. Hydrochloric acid over here on the right. Hey, all right there. We got the PhD in chemistry has entered the chat. So G Walks, you got some questions? G Walks can answer them too. All right. What part of chemistry do I find the most difficult to remember? Asked that special keynote. The parts that I find uninteresting. All right, we're gonna. Hello there, Donald. Rick, what I'm doing over here, let's focus on this one. Thank you there, Marcelo. What I'm doing over here on the right is I have in this flask a universal indicator, also known as rainbow indicator. It displays a variety of colors at various pH levels. All right, right now it's red, and that indicates to me that the pH is 3, which is acidic. So here's the various colors that you'll see, all right? Various colors that the universal indicator displays. All right, I'm going to now start adding drops of base. So in goes 1 drop of a base, and it looks like the pH has risen a little bit, maybe to pH 4, yeah? Hey, Minty, I have mixed sodium and water. I've done that in some of my my videos. Yeah, what's your question there, Christopher? All right, let's add another drop of base. Let's see what the pH goes to. It looks like it went to green, so it's getting up there, yeah? So we're at neutral. I'm going to add another drop of base over here on the right. Kion, I went to University of Michigan. So now we've got an excess of base, and so now it's violet. Hello there, Zoe. Now we're going to do the opposite. We are going to drop the pH using, we're going to drop the pH using acid. We got the Boltzmann distribution in the chat. I'm loving it. Hello there, Kevin. Here we go. 1 drop of acid. We went from pH 10. It looks like we're still at pH 10. Let's add another drop of acid. The acid I'm adding is hydrochloric acid. It's the same acid that's found in your stomach, except it's like 100 times more concentrated. Hey there, the weird one. pH Lone Star is a measure of the concentration of protons in the solution. I'll say that again. It's a measure of the concentration of protons in the solution. And that, the more protons in the solution, the more acidic it is. And just the way the mathematical definition goes, the lower the pH, the higher the proton concentration. Will I make an amalgam with aluminum and mercury? I won't. I don't mess with mercury. Okay, here we go. I'm going to add another drop of hydrochloric acid. Notice we're at pH 8. I'm going to add a drop of hydrochloric acid. In it goes. And looks like we've gone from pH 8 to pH 7. I'm going to add another drop of hydrochloric acid. And Neptune, I don't know how much an entry-level chemist makes. Sorry, I can't answer that. We're down to about pH 5 now. Aluminum and gallium, Minty, I might try that. Let's add another drop. There we go. And we are down to a pH of like 3. Pretty cool. Pretty cool. Let's go over here and look at this one over here on the left. This one has a different indicator system in it. A different indicator system. Let me go ahead and add a stir bar to this one over here on the left, like that. Get that stir bar going. There's also a piece of dry ice floating around in there. That's what's making the bubbling. I'm going to go ahead and start adding base to this over here on the left. And you can see this indicator system turns pink in a base, but then it fades back to colorless. That's because there's a lot of carbon dioxide in here, and the carbon dioxide's acidic. Let me try to really squirt it in. There we go. Make that really basic. And over time, that should go here. I'll add some acid to it so we can make it go back to colorless. Although that's not really as interesting as I'd like. Oh, man, I can start to see yeah. I can start to see a little bit of bubbling forming here. Let's go back over here. How does it turn purple? Ask E21. That's because there are a mixture of dyes in here that change color as you add base. So I'm adding the base right now. Got a little rainbow action going on there, which is kind of cool. Marcelo, I do lives usually on the weekend. Usually it's Friday evening, but I didn't get a chance to do it this Friday evening. I was actually doing some chemistry shows, some Halloween chemistry shows. I did quite a few this weekend, and what I'm basically using is the excess material here for this live. Come on, that was some beauty over here. Wasn't that cool? That was really beautiful. I agree there, 747, if I can figure out how to get this sealed up. I'm going to add a few more drops of acid over here on the right. And that's going to change that to a red color. Now I'm going to start adding drops of base, one at a time. There we go. Couple more. Yeah, I got, there we go, a little rainbow action. I love it when that happens. It's so beautiful. The base I'm using, man, is 20% by weight sodium hydroxide. Marcelo, I find it kind of artsy too. Thank you there, Zoe. Zoe just subscribed. I appreciate that. I'm going to add some more base here. We're trying to get to 500,000 subscribers, folks. We're getting close. We are getting close. I'm not doing any fire experiments tonight. No fire experiments tonight. Okay, now we're at a high pH. It was there for a second, Neptune. We're at high pH, yeah, pH 10. Yeah. So now I'm going to start. Thank you there, man-like. Appreciate that. I'm going to, for the sub. Thank you there, ATL. More hair on my arm than a chimpanzee. You got it, man. Check that out. I definitely got some hairy arms. I take after my grandpa. Every time I see my arms, I think of my grandpa. He had really hairy arms. Sure, Trinidad, you sub. You tell me what color you want. I'll change the color for you. Both there, Golden. I do both. Okay, here we go. I'm going to add a drop of hydrochloric acid, the same acid found in your stomach. I added a drop over there on the right. So EAA wants it red. We're going to head there, man. We are heading there. Thank you there, Jay Trindad. Jay Trindad, getting some salt. We're going there. Hey, Bren, what we're doing is we're adding either acid or base to a mixture of dyes called universal indicator that change color depending upon pH, and pH is just how acidic or basic something is. Money Monkey, I'm going to try to get you some green here. So to do that, I'm going to add acid to lower the pH. Acid lowers pH. You can see the red color there in the middle. We're going, man. We are going. We are trying to make it green, and then I got to make it red for some folks who just subbed. Oh, I think I'm going to... There's your green. Oh, it's maybe a little yellow. Little yellow. I'm gonna call that green. What do y'all say? You gonna let me call that green? Okay, and I'm gonna keep adding acid. So we're about neutral. I'm gonna keep adding acid here. Thank you there, Money Monkey. All right, we're gonna keep adding here. As I add the acid, you'll notice the green shifts to a red. Indeed, I am a wizard. I even got my wizard costume on. Here, we'll flip it around. You can see. I got the wizard hat on. I am a wizard. Flip it back around. All right, let's get back to the experiment. You don't want to see that old man's face. Okay, let's now add a drop of base. Thanks, man. Thank you there, Jay Trindad. Oh, somebody said they want teal. I am so sorry. Teal is really difficult to get. I'm going to go for it. I'm going to go for it. Do you add sulfur to make... I'm not adding sulfur. I'm adding sodium hydroxide. What's different with the one on the left? Why isn't it strong? So the one on the left... Yeah, hold on. I gotta get this to a teal color, and then we'll talk about the one on the left. I actually want to try to set up a different experiment. Notice I added this drop here. It's like half a drop. I added just a little bit of acid. Just a bit. I'm going to get that drop in there, and we're going to see if we can't pull this to a teal color. Nah, I went too far. Oh, I can't get it to black. I apologize, Jay Trindad. I can't get it to black. I think I may have... I'm going to add another just partial drop. You do that by adding just a little tiny drop to the side so it adheres to the wall. You see it? I've added it right there. Right there it is. And then I just tip it, and that little bit of base will go in there. I'm really trying to fine-tune the pH. Somebody wanted teal, so I'm trying to get from 7 to 8. Come on, baby! Come on, I think I did it. There's your teal. I got you teal. Yeah, Stephen, copper will make solutions teal. They will indeed make solutions teal. What kind of acid is this? It's actually stomach acid. It's just a lot more concentrated than stomach acid. Thank you there, Josie. Appreciate it. Yep, we're increasing the hydroxide for sure. Increasing the hydroxide for sure. Let's see, do I got enough water? I don't. What is this? Let's try it. I'm going to try a different flask, okay? We're going to set this one up over here. You guys will like this, trust me. You're going to like this. Let's just get it ready. I guess I'm going to have to use a slightly smaller flask. Yeah, I don't have a big one ready, do I? That's too much. Slightly smaller flask. Come on, man, where'd I stick my flasks? There's one. There's one. We'll do a slightly smaller one over here. I'll get this one filled with water. Here we go. Get the water in there. Okay, this is going to be fun. We're just going to use a single color indicator in this one. Let me get a stir bar going in here. And it goes. Got it spinning around. All right, now what I'm going to add to this one is just one dye, and that dye is called phenolphthalein. So you can see me adding it right up here. Over here, I'm going to add some phenolphthalein dye. Like 3 drops, okay? 3 drops of phenolphthalein dye. Phenolphthalein only undergoes 2 colors. It's either colorless and acid or neutral, which is what I can see now, or it's pink. So I'm going to go ahead and add some base. Here we go. Over here on the left, I'm going to add some base. And you can see that pink color just grow in like that. Isn't that gorgeous? Isn't that gorgeous? And then I'm going to add a drop of acid over here to the phenolphthalein. YKG, you got it. I'm going to try to make orange for you, okay? Let me just try to add enough acid over here to make the phenolphthalein go back colorless. What I like about this experiment, I don't mean to be sacrilegious, but it's just kind of fun. You know, it's like water into wine, yeah? It's kind of what it looks like as I add the base. And, you know, I like to say I'm an equal opportunity miracle worker. I'm going to change that wine back to water by adding acid. So the phenolphthalein that's in here, it's either colorless in an acid, which is what I'm trying to do right now, trying to make it colorless, or it's pink colored in a base. Boy, I got to add a bunch of acid here. I think my acid's a little... There we go. There we go. Is it going to go? Is it going to go colorless or is it going to stay pink? What do you think? The thing at the bottom of the glass is a little magnetic stirrer. I don't do lives about mixing metals, although, Marcelo, I think you're going to like my videos that I have out on Gallon Stand, which is a mixture of 3 metals, gallium, indium, and tin. It is pretty crazy. Pretty crazy. Yeah, Connor, we're going to go ahead and time you out if we're going to spam, all right? I'll be checking that out. I don't want to ban anybody, but yeah, come on, man. Don't be doing that kind of stuff. All right, here we go. I'm going to start adding acid here to the one on the right. Here we go. So long there, Zoe. We're trying to go for orange right now. I think I hit your orange, yeah? Hit your orange. The acid I'm using is hydrochloric acid, 20% by weight. Thank you there, Animal Editor. All right, let's go all the way to red. I got rid of them. All right, a little red here. One more drop. Yeah, I'll try that vid on. We'll try getting the blue. So what I have in this flask over here is a universal indicator. It's also known as rainbow indicator. It's a mixture of dyes. It shows a bunch of different colors at different pH values. Right now we're at pH 3, which is red. I'm going to start adding drops of sodium hydroxide. There's 1 drop. The pill at the bottom is just a little magnetic stirrer. So I added 1 drop of acid, and you can see the pH has gone from 3 to like 4, 5, or 6. All right, I'm going to add another drop of base. And you can see we went from pH 6 to like pH 7, maybe 8. And there's your blue at the bottom, like a little teal. Goofy, I'm going to try to get you your blue here. Hopefully this drop will do it. I'm a little concerned it's going to go violet if I add one full drop. So up here at the top, you're going to see I'm going to pinch just a tiny drop. And I still overshot, didn't I? So I went to pH 10. I got to pull the pH down to 9. So I'm going to try to add just a tiny drop of acid. I'm going to try to put that little drop right there. You can see I adhered it right there to the side. And I'm just going to tip the water, and hopefully that's just enough acid to pull the pH from pH 9, 10 down to pH 9, which will give us a blue color. Blue's tough to get. Blue is not easy. What's interesting is if you look closely, you can see a thin red line going down through here. That's where the acid is. And then when it hits the bottom, it gets spread out. I didn't quite add enough acid because we're still at like a pH 10. So let's add another tiny drop like I did before. Forgive me when I do this. I'm paying attention to the experiment and not the comments. So I won't be reading these so much right now. There we go. I got a tiny drop right there at the top. Let's let her in. All right, we'll do some pink. Somebody wanted to see some pink. Hopefully I can get it to blue. Go blue, Emmanuel. Hey, I got an experiment for you, Emmanuel. If you hang out, you're going to like it. Clear means transparent. So this over here is clear and purple. I'm trying, man. I am trying to get to blue. Y'all are making this difficult on me, but let's do another drop there. Let's see. There we go. Another little drop of acid. Let's see if it goes down. There we go. I think I got your blue. There it is. I'll add another full drop of acid. That might get us down to a pH 7, which would be green. Let's see. It is a little pretty. I want to actually try to get the rainbow effect going on. That's really cool when that happens. I'm adding a bunch of acid to the middle. Look at there. We got it, baby. Come on now. Little rainbow action. I'm loving it. The rainbow tornado. Come on, baby. It's just beautiful. Just beautiful. Never doubt the power of science. I'm loving it, man. I do too, Peachy. The rainbow is my favorite. Here we go. I'm going to add a bunch of drops of base here to the middle. See if we can't get that rainbow effect going on. 3 drops. Let's see what happens. There we got it. Little violet, little red, little blue, little green. No, I don't know how to make cinnamon flavor with paint thinner. That's not me, E21. I'm not a synthetic chemist. The base I'm using, Gabby, is 20% by weight sodium hydroxide. It was pretty. Let me show you this experiment. You guys are going to like this. I think you're going to like this. Let me, what do I got here? Oh, I don't know if I have the... Oh, I don't see the materials for it, so we're out of luck. Yeah, I don't have it. All right, we'll just pass on it. Let's look over here. Somebody was asking for pink. I am Evo. I am a chemist. So over here, we have a different indicator. So this system over here shows these colors at different pH values. That's this system. This system has a different indicator system in it. This indicator system only shows 2 colors. It's either going to be colorless in an acid, a neutral, or it's going to be pink in a base. So right now it's colorless, so I'm going to add some base. Here we go. I'm going to add it right to the middle. And you can see the color shift to pink. Isn't that beautiful? It's like water into wine, baby. It's like water into wine. Isn't that gorgeous? This pH indicator is called phenolphthalein. And now I'm going to change it back to acid. To colorless by adding acid. So it's like water into wine and then wine back to water. So right now I'm adding drops of 20% by weight hydrochloric acid over here on this side. And you can see that color shift back to colorless. I think this might work. I'm going to give this a shot just for the heck of it. I can't do white to black for you. I apologize. Can you make the pH one invisible? Marcelo, this one will not go invisible unless I get all the dyes out. The base, Gabby, I am using is 20% by weight sodium hydroxide. No, this one won't go colorless. All right, we're going to try this now. So what I'm going to do is I'm going to take, this is a fun little experiment. You got it, Gabby. I'm going to take some water. I got water? I do. We're going to take, I don't know. Is that actually going to work? We're going to try. we're going to take about, I don't know, 50 mils of water. So here we go. 50 mils of water. In it goes, yeah? There's my 50 mils of water. And I'm going to stick that into this container right here. Oh, I want to get that stir bar out of there. Get the stir bar out. There, this one's already got it out. Oh, there we go. So there's my 50 mils of water. Better make it 100. Better make it an even 100. So in goes an even 100. There we go. Even 100. And then I'm going to take some 70% isopropyl alcohol. Wait till you see it, Play-Doh. We're just making an experiment here. So we're going to do 100 mils of the 70% isopropyl alcohol. In goes that. Right there. That's going to get mixed in with our water. So hopefully it won't be too much. It's kind of interesting looking, yeah? That's going to be perfect. Okay. Now I'm just going to take this. I'm going to put it in this flask right here. Let's just pop all that mixture in the flask. Get it in there. And here in the great state of Michigan, we had an interesting football game yesterday. And this experiment is meant to highlight that particular football game. And what do they say? It was Michigan versus Michigan State. And my kids, some of them went to Michigan State. And you know what we say in Michigan State? We say, go green. I'm going to add a drop of green to this. Maybe 2 drops, all right? There we go. Go green, baby. Go green. Good night there, Sydney. And, of course, the other part of the Michigan State chant is go white. So I got some white colored powder here. So in goes the white. Go green. Let's do a little more white just for the heck of it. Go green, go white. All right, in it goes. Let's swirl that around. Beautiful green color. What do you think is going to happen? Go green, go white. Let's pour it in here. And let's see what happens. Yeah, my kids went to the Michigan State University. Of course, the colors of Michigan State University are green and white. That's why you chant, go green, go white. But you know what, folks? My kids went to Michigan State, but I went to the University of Michigan. And the colors of University of Michigan are blue and gold. Maize and blue, baby. Isn't that awesome? Isn't that cool? Isn't that a fun little experiment? So question, how did it do that? Of course, how did it do that? Well, here's how it works. Here's how it works. You remember, I mixed 2 liquids together. I mixed together alcohol, isopropyl alcohol, and water. So those are 2 different liquids that I mixed together. The green that you're seeing, by the way, is just an effect of it's an optical illusion. That's actually separated into 2 liquids. So I mix together isopropyl alcohol and water, and those usually mix very well. They mix extremely well, okay? The isopropyl alcohol and the water mix together very well. And the green dye is actually made of 2 different colors, blue and yellow. It all mixes together very well with when it's all mixed together. However, when you add that white powder, it's a salt. And what that salt does is it's really attracted to the water. And so though, just like when 2 people are very attracted to each other, they date each other exclusively and they push everyone else out, the salt and the water stick together really strongly and it pushes out the alcohol. And the alcohol is less dense, so it floats to the top. The salt water is more dense, and so it floats to the bottom. But what's interesting is the green dye, there's 2 parts to it, blue and yellow. The blue part likes the alcohol layer better, and the yellow part likes the salt water layer better. So you can take that green dye and separate it into maize and blue. Isn't that cool? Very cool. All right, let's get back to this experiment over here. Thanks for joining in on my goofy little experiment with Michigan State. Let's do some experiments over here, baby. Let's get back to these. Oh, I'm sorry, Marcelo. I missed it. I was paying attention to the experiments. I wasn't watching the comments. That's my apologies. The powder, JT, was potassium carbonate. Potassium carbonate. So long, Marcelo. So long. Thanks for hanging out. Yep, we're looking at pH levels. I'm going to add a few drops of acid over here. A couple drops of acid. The acid I'm adding is hydrochloric acid. Same acid's found in your stomach. It's just the stuff that I'm adding is like hundreds of times more concentrated. All right. A couple more drops. And now I'm going to add some base, and I'm hoping I'm going to see the rainbow effect. Let's add a few drops of base. The base I'm adding is 20% by weight sodium hydroxide. There it is. Come on, baby. Thank you there, Tatiana. I appreciate that. Can you use the salt trick with regular? Yes, you can, Eckelhaft. You can. You just got to, fiddle around with it a little bit. Here we go. A few drops of acid. We're going to lower the pH. Thank you there, Tails and Moho. It's gorgeous. Just gorgeous. And here's another effect that you might have noticed. I'll talk about it a little bit. How badly would a hydrochloric acid burn if it made contact with your skin? It would just start itching. It wouldn't feel real good. So I want you to notice this. You can see it a little easier when it's yellow like this. I'm going to add some acid, which is going to pull the pH, lower. Watch where it happens when I add the drops to the center. You see how that red stays in the middle? That's where the acid is. The red material tends to stay in the center of the vortex until it hits the bottom. Thank you there, Bill Waters. And then it gets spread out. Yeah, and now I'm going to add some drops of base. Same thing's going to happen, right? I'm going to add a few drops of base. The violet color stays in the middle until it gets pushed down and pushed out around the sides. We got a little rainbow going on, baby. Come on now. The reason, here, I'll slow it down. We can see it a little better. We can see it go a little better here. Add some drops of base. The reason why the material stays in the center is because just like the eye of a hurricane is low pressure, the eye of this vortex, the center of this vortex is low pressure. And things tend to move from high pressure to low pressure. So if it's already in a low pressure zone, it's not going to move out. It's not going to move out into the high pressure region. I'm adding acid to the center right now. It's a little harder to see the acid through the dark violet. Boy, that looks like the northern lights breaking through the nighttime, doesn't it? Very gorgeous. Very pretty. I don't have any cesium. I don't have any of that either. I can't teach you how to make those rockets. I apologize. So, easy to hard. I don't know how to do that. Thank you there, Tatiana. Thank you there, Bill. All right, let's add a few drops of sodium hydroxide base. See if we can get the rainbow effect going on. I wouldn't drink it punched. One of the dyes is a laxative, so that might end the live in about 15 minutes if I drank it. Easy, you can do that using a compound called potassium chlorate, and I actually have some videos on my channel. I actually use potassium chlorate as an oxidizer and a Lego block as my fuel. And you could actually use that. They actually use the compound found in Lego bricks for rocket fuel sometimes. Thank you there, Mark. I appreciate that. Thank you there, K1. It is a little bit like art. I think so. What I like about it is I don't have to be the artist. You know what I mean? You just set things up and you let nature do its thing. Thank you there, Joel. You're not going to get on any watch list. Watch list. I do a lot of, I'm looking all sorts of stuff up with chemistry. I'm just curious. Thank you there, Petru. Thank you there, Mike. I appreciate that. Leon, we're going to try to make it green for you, buddy. If it wasn't a laxative, how safe would a neutral pH be to drink? Kraziatio, I'm sorry I'm saying your name wrong. I don't know the toxicity of the other compounds in Universal Indicator. Yes, Tatiana. I mean, I spend hours doing this for folks, so yeah, I find it very interesting. So I don't particularly know. I would not be the person to ask on, how safe it is to drink this. Hey there, Neuropalm. What happens if you drink acid? Jesus, you probably have drank acid before in your life. If you've ever drank lemonade or orange juice or soda pop, you have consumed acid. Um, and there are acids in your body that keep you alive. For example, vitamin C is ascorbic acid. Thank you there, DI. I'm no Walter White. Walter White was what we call a synthetic chemist. A synthetic chemist is somebody who knows how to make a particular compound or who, tries to invent new compounds. And I'm not much of a synthetic chemist. Thank you there, Jim. Trent seems to be finding use in psychological therapy, as far as I can tell, as long as it's used appropriately. Yeah, there are, Baba. There are particular acids that can eat through metal quite quickly. Sure are. What's the difference between a base and a neutral and an acid? Asks Jesus. To a chemist, an acid is a substance that donates protons into solution. You can also think of it as donating hydronium ion. Um, it's just this little H plus ion that gets transferred to different molecules, and acids are compounds that donate those H plus ions. A base is a substance that accepts those H plus ions, so they're like chemical opposites of one another. That's correct, Cracky. An acid tastes sour, and bases do not taste sour; they tend to taste bitter. Okay, somebody wants it blue for their birthday. Come on now. Hey, thank you there, person from Puerto Rico. Lilo, appreciate that. What happens if an acid touches lava? Well, it depends what the lava is made out of. Aries, it depends. I did, Nando. I said acids donate protons. That's correct. H plus ions is probably more appropriate, but an H plus ion is a proton. I don't know how else to. Yeah, we got to purple for sure. Yeah, weirdo. I've got some glasses on to keep this out of my eyes. I don't want this stuff getting in my eyes. It's concentrated enough that it would sting pretty bad, and I'd have to rinse my eyes for a while. Types of acids that could disintegrate metal. Hydrochloric acid can disintegrate zinc. It can also disintegrate magnesium. Hey, AJ, what's going on, buddy? Um, I don't know what that tastes like, Michael. I just know what it can do to a scrub daddy. I put a scrub daddy in piranha solution once. I'm trying to get this blue, and then we'll try to go to green, okay, Aziz? So I'm going blue first because somebody's birthday. There's your blue. I got your blue. It's a little teal blue, but I think that's blue. All right. Yes, Mike. It could destroy your eyes if you got enough in there. Am I a wizard? Asked Jem. Well, let's see. Am I a wizard or am I a wizard? All right, nobody wants to see that old man's face. Let's get out of here. Back to it. There's your green. There's your green. When you mix it, Leon, and it gets green, would it be safe to consume? I wouldn't consume it because one of the dyes in there is a laxative, and that would end the live in about 15 minutes. Here, let's look at this one over here. This is kind of fun. Thank you there, Goofiest. This one's over here is a little different. This one just shows two colors. I'm going to get this one going. Thank you there, Goofiest. So we're going to get this one going. This one shows two colors. It's either colorless and neutral or acid. And in a base, the strongest acid is fluorantimonic. Excuse me. Oh, yeah, I think it's fluorantimonic acid. I'm going to add some drops here. I might be saying that wrong. Somebody Google it and correct me. There we go. There we go. Green, buddy. There's your green. We got like Joker colors going on right now. Tatiana, yeah. Oh, you know what? At the end of the live, I usually talk to folks, so I'll spin it back around. We'll stop doing the experiments. It's probably the end's coming probably pretty soon here. I'm adding acid over here on the left, so we're gonna try to change that that pink color back to colorless. Thank you there, Cracky. Do you know I don't know what you're saying there, Aries. I apologize. I apologize, Aries. I don't know what you're saying. I can't make it black. Goodbye, Pink, says Crackety. Yep. Let's try and get the rainbow effect going on over here. So I'm going to just add a few drops of base to get us to pH 10. And then we're going to start to add drops of acid. The acid I'm adding is hydrochloric acid, same acid that's found in your stomach. And we're going to see if we can't get a variety of colors in there. What's up there, K's Ordinary Life? It's like a... That's kind of cool, man. Look at that. We got a little rainbow action. Easy to hard. You can... There are some... in the pharmacy, there are some cold packs, you know, the kind that you hit, and then there's a water pack in there that gets broken, and then that mixes with the salt, and then everything gets really cold. Some of those contain potassium nitrate. Some of them. Here we go. I'm going to add a little more acid over here on the right. Hydrochloric acid, same acid's found in your stomach. You're welcome there, Zakar. Thanks for hanging out. Rainado. I love it. Here we go. Let's add some base. Try to raise the pH. See if you get the rainbow effect going on. What other science stuff do I do? I mostly do this experiment, but yeah, I just do goofy stuff. You guys want to see the you guys want to see this experiment again? Thank you, they're easy to hard. Y'all want to see this experiment? How I make this? Y'all want to see that one? Two different colors separated with a blue and a violet. Excuse me, a blue and a yellow. All I do is I acidify it and then I save it because when it's acidified, no bacteria grows in. I just reuse this. Yeah, I mean, some people like to call this the Ukraine reaction. Some people like to call it the Michigan reaction. Yeah, let's do it. I'll do this one for you. We'll do this one, okay? Oh, Viten, I got to make you orange. All right, before we do that, let's see if I can make this orange real quick. I'm going to do my best. Happy birthday there, Viten. Let's see if we can't get it to orange. Come on, get it to orange. I think we got a little orange stream going on there in the middle. There it is. There's your orange. Happy birthday. Happy birthday. Okay. Here we go. All right, Zakar. This is for you, Zakar. This is for you, Zakar. Zakar's from Ukraine. He wants to see this. I don't know. Sorry, I don't know. But they want to see this particular reaction. So we're going to give it a shot here. We're going to give it a shot. I hope I have enough water. If I have enough water, this is going to be a very short experiment. I think I got it. Okay. I'm going to pour this into here. And let's show you how we do this. Okay. First thing I'm going to do is pour 100 milliliters of water into this flask. Here we go. We're going to make the Ukraine water. Or the University of Michigan water if you don't want it to be Ukraine. So there's 100 mils of water. All right. And that's going to go into this flask right here. 100 mils of water. Excuse me. Yep, 100 mils of water. And then into this flask, I'm going to pour 100 mils of 70% isopropyl alcohol. In it goes. Hope I don't spill. My wife would not be happy with me. All right. So 70% isopropyl alcohol, 100 mils, and 100 mils of water. So ultimately, this is like 35% isopropyl alcohol is what it ends up being. Okay? Swirl that around. Oh, crap. I don't have any more of the salt. Oh, shoot. Oh, I can't get it to work. You know what? We'll try it. This won't work perfectly. You're not going to make Ukraine. I apologize. I don't have the right salt. But what I'm about to add should work. Curses. I apologize. It's not going to work as well as I would hope. Anyway, we're going to add a drop of green food coloring. Actually, 2 drops. 4 colors. I can't get you 4 colors. I can't get 4 separations. So let's do 2 drops there. 1 drop, 2 drop. There's our 2 drops. Yeah, sorry about that. And now I'm going to add a white solid. Let me get my white solid here. By the way, the white solid that I am adding is simply sodium carbonate. This stuff. All right? This works. All right, let's get that in there. I don't know if that's 25 grams or not. It's actually probably too much, but in it goes. Down the hatch. All right, let's swirl that around till it looks like it's dissolved. And then we're going to pour it into, I think I added too much of the solid, but that's okay. We're going to pour it into this flask here, and we're going to hope for the best. This is sodium carbonate. It works better if you use potassium carbonate. I'm using sodium carbonate here. Just pouring that in. And I'm going to hope for the best, folks. Hope it works. Let's see. That might be a dud. I think it's a dud. Oh, my experiments don't always work. Curses! Oh, I'm so sorry. Shoot. I'm going to try to just mix it a little more. Maybe I can get a bit more to dissolve. Come on, baby. Let's shake that up a little more. Maybe I can get a little bit more of the gunk to dissolve. And if I do that, it might work. I'm so sorry. I don't think it's going to work. But I'm going to keep trying just a couple times. Get enough of these. All right, here we go. Let's see if this helps. Come on, baby. I might have the ratio off just a little bit. All right, let's see. Let's see. Oh, it's going. It's going, I think. Is it? Ah, I'm sorry, y'all. Yeah, the science has let you down. I apologize, everybody. I'm so sorry. Very, very, very sorry. My experiment failed. It happens sometimes. I didn't have the right solid with me. So I apologize. It happened earlier in the live, but this time it screwed up. That's my bad. My bad. Thank you there, Mohammed. I appreciate it. So hey, folks, we're gonna switch to the end of the live here pretty soon, where I'm gonna flip around the camera. Just warning you now, you're gonna see an old man in their basement doing some experiments. If that's something that's not your cup of tea, now's your time to head on out of here. We'll be talking to folks. Just talk about life and science and chemistry and all that good stuff. So yeah, you're gonna see my ugly mug. So just watch those watch those numbers drop. Anyway, I still like to talk to y'all for hanging out with me. And I'm going to keep swirling this just to see if it shows some separation while we're talking. But you don't want to sit there and wait for me to see that happen. So, okay, let's go ahead and head to the end of the live here. Yep, I got my wizard hat on. Happy Halloween, everybody. Happy Halloween. So what's everybody doing this evening? I don't know, Jesus. I can't help you with that. Thank you there, Wald fan. Happy Halloween, Jace and K Misty. Thank you there, Bluncy. Thank you, everybody. Thanks for hanging out. Cast a spell. That's what I've been trying to do all night, but this one didn't work so well, yeah? This one didn't turn out so well. I don't think it's going to separate like I was hoping for. Happy Halloween, Goofius and XS. Thank you there, Jesus. So long there, Ladashi. Thank you there, Jesus. Happy Halloween, Cassie. No, Bluncy, it just keeps changing back and forth. It is another word for magic. Yep. Have a happy, safe Leviosa. Come on. I love it. Ashcott, we were actually doing some chemical reactions. So those color changes that you were seeing in this particular flask, those are actually these are chemical reactions. So that's a chemical reaction. The chemical identity of the dyes in there are changing. You have different chemicals that are giving you the different colors. Yep. RV, this was just a failed experiment. It didn't quite work out the way I was hoping. Thank you there, Cracky. Thank you there, XX. Columba, I apologize. I can't read that language. I'm so sorry. But thank you for hanging out. Come on, Cassie. That's a great word. Spectropotonium. Let me go back and look at that. Spectropotonium. I love it. I love it. Oh, cool. Somebody did some DNA extraction. That's fun. How do you get to swirl like that? That's what these Erlenmeyer flasks are made for. You just kind of pinch up here at the top and you just swirl. That's it. Thank you there, Kelly. Happy Halloween, folks. Can I make a polyjuice potion? I can't. Thanks for hanging out there, Chaos. Chaos. Fam, I'm not going to talk about that stuff on my lives. I avoid politics. Not that I don't get myself involved in it, but I let's keep it light here, man. Let's keep it light. Thank you there, XX. I bet, Jesus. Thank you there, Grim Childish. Well, that's my live for the weekend. Thank you for hanging out. Thank you for checking out some of the beauty of science with me. It was fun, man. I had a good time. I hope you had a good time too. I might try to do some more Halloween experiments once Halloween starts rolling around. But hey, thanks for being here. Thanks for looking at the beauty of some of the science experiments that we've seen. And always be looking for it, man. I mean, the whole universe, there's miracles all over the place. The miracle of science. And the beauty it's just there for us to see. So thanks for seeing some of that beauty here with me tonight. And I'll be seeing you in my next live. Thanks for hanging out. Love y'all. Thanks for making my dreams come true of being able to do science experiments for people. I totally